All right, so today we're diving into the world of Jadoin Farmer and his book, Making Sense of Chaos. We're really trying to get a grip on this idea of the economy as this, well, kind of a force of nature.
It's definitely a different way of looking at things because, let's be honest, traditional economics has a hard time with anything unpredictable.
It's like they're trying to predict a hurricane by, like, checking the average temperature.
Yeah. In fact, Farmer calls this the rocking horse economy, where everything's explained by these external shocks.
Instead of, like, I don't know, the horse actually moving its legs.
Exactly. Complexity economics, which is what Farmer's all about, tries to figure out the internal dynamics, the stuff happening inside the system.
So understanding the horse, not just what's pushing it. And this is where it gets wild. Farmer's journey into all this starts with predicting roulette.
You read that right. It sounds crazy, but it highlights this whole idea of chaos theory. See, he and his buddies built a computer, right? And this thing consistently beat the house at roulette.
Wait, hold on. So he was like a card counter, but for roulette?
Kind of. But it's more about the science behind it. They showed that even the tiniest change at the start could totally change the outcome.
So like the butterfly effect, but for gambling.
Exactly. And this has huge implications, way beyond gambling, because what they proved is that even in things we think are random, there are patterns.
So much for that efficient market hypothesis, huh?
Well, Farmer's own trading firm did pretty well for like 3 decades, so he's got a point. There are inefficiencies in the market, and they made a lot of money exploiting them.
Okay, so he proved the experts wrong and made bank. But how does that asterisk connect to something like, let's say, the 2008 crash?
That's where his market ecology idea comes in. He's basically saying that all these different financial strategies, they're like creatures in an ecosystem.
A financial food web. Who are the predators there?
Think of the aggressive, high-risk investors. They use a ton of leverage, borrowed money to try and get huge profits.
And they don't care who they hurt in the process.
Pretty much. And then you've got the more cautious investors who can become prey if they're not careful.
And when those big players, those predators, they get greedy.
Hmm.
That's when things go south.
Exactly. That's a big part of what Farmer says happened in 2008. Too much leverage, too much risk.
So like a boom and bust cycle, but supersized.
Right. And Farmer says the key is to understand these predator-prey relationships, but also to get smarter about regulation.
So less about bailing water and more about, like, plugging the leaks before they happen.
Precisely. He suggests these things called agent-based models. Think of it like a flight simulator, but for the whole financial system. We can test policies and see what happens before they're implemented in the real world.
That sounds amazing. But aside from avoiding crashes, Farmer's also got thoughts on climate change. What's his take there?
You might be surprised he's actually pretty optimistic. He argues that transitioning to green energy, if we do it right, won't bankrupt us. He actually thinks it could save us trillions.
Hold up, save us money. Most of what we hear is about how expensive going green will be.
Right, but Farmer backs it up with data. He points to how the cost of renewable energy, things like solar and wind, has been dropping incredibly fast.
So we can fight climate change and save money. That's a pretty bold claim.
It is, but he's got this model, the Climate Policy Laboratory. It's less about predicting the future exactly and more about looking at all the different possibilities.
So like a choose-your-own-adventure book, but for the climate.
Exactly.
Yeah.
It factors in things like technology, political decisions, and economic trends, and shows how they could impact our transition to a low-carbon economy. It can model, for instance, how much investing in certain technologies or using carbon pricing will affect emissions and economic growth.
That's incredibly useful for anyone making policy, especially if it helps us avoid those worst-case scenarios everyone's always talking about.
Absolutely. But even with these complex models, Farmer admits economics, unlike, say, physics, will always be unpredictable to a certain extent.
So no perfect crystal ball for the economy.
Afraid not. But that doesn't mean we're totally in the dark. Farmer believes that we need to shift from trying to eliminate uncertainty to becoming more resilient.
So instead of being scared of the unknown, we should learn to roll with the punches.
Exactly. And that's where understanding complexity comes in. By really digging into how economic systems are connected, we can design policies and institutions that can handle shocks and adapt. We can build a stronger, more flexible economy that can weather the inevitable storms.
So like designing buildings to withstand earthquakes. We can't stop them from happening, but we can minimize the damage.
Perfect analogy. And that goes for our financial markets, our energy systems, even our social safety nets. If we can understand and embrace complexity, we can create a more stable, fair, and ultimately more successful future for everyone.
That's a powerful message, and it feels like a good place to pause for now. We've covered a lot, from roulette to financial crises to climate models, all through the lens of Jadoin Farmer and his work on complexity economics.
It really is a lot to think about. It just shows you how connected everything really is, and we've really just scratched the surface of Farmer's work here.
So, where do we go from here? What else has Farmer found out about complexity economics?
One of the most interesting things is how he takes these complex systems and uses them to look at the job market.
Okay, so from predicting crashes to predicting careers.
It's kind of like that. Farmer has done some really interesting work on something he calls occupational transitions. He looks at it all from a network point of view. Imagine each job as like a point on a map, and the lines between them show how easy it is for someone to move from one job to another.
So, like, it's probably easier for a marketing person to move into sales than to become a brain surgeon.
Exactly. There are natural paths and roadblocks in the job market, just like in any other complex system. By analyzing this network of jobs, we can start to see how changes in one area can affect everything else. We can see where the holdups might be, what new jobs are popping up, and how things like automation and technology are going to change what jobs people do.
That's really useful information, not just for people looking for jobs, but for governments and schools too.
Absolutely. It could help us be more prepared to retrain people for new jobs, figure out what industries are going to be big in the future, and even help us decide what to teach kids so they have the skills they need.
It's like we'll have a roadmap for what jobs will be like in the future. But to figure all of that out, you'd need a ton of data, right?
You're totally right. And that's where these agent-based models that Farmer loves come in. Remember we talked about those? They're like simulations for the economy.
Right. It's like that flight simulator for the financial system. But this time it's for the entire job market. We're getting really good at these simulations.
Well, it gets even more interesting. Instead of just looking at the big picture, these agent-based models let us zoom in and see how each person's decisions can affect the whole system.
So we're not just treating people like data points anymore. We can actually factor in how unpredictable we can be.
Exactly. These agents in the models can be really simple, just following basic rules, or they can be really complex, able to learn from their mistakes and make better decisions next time.
It's like we're building a tiny virtual society inside a computer. But how realistic can we make them? Can we really get these agents to think like real people?
That's the million-dollar question, and it's a challenge that researchers are working on all the time. They're always trying to make the models better by using what we know about psychology, sociology, even how the brain works, to build agents that make more realistic decisions. They're looking at emotions, biases, even how our friends and family influence our decisions.
So we need to take the hard data of economics and combine it with what we know about human nature.
Exactly. And if we can do that, these agent-based models can help us understand not just what might happen, but asterisk, why asterisk it might happen. They can show us those unpredictable patterns and behaviors that happen when you have a lot of individuals interacting.
Can you give me an example of that kind of unpredictable behavior in the job market?
Think about when smartphones first came out and suddenly everyone needed an app developer. No one planned for that to happen, right?
It just kind of happened.
Exactly. It was like a chain reaction with all these programmers learning new skills, entrepreneurs seeing a need, and people wanting these new apps. It's that kind of back and forth, fueled by all these different factors, that traditional economic models have a hard time explaining.
So are you saying agent-based models give us a new way to study these changes and maybe even see them coming?
That's exactly it. When we add in how people actually behave, the effects of networks and the feedback loops, these models become really powerful. They can help us figure out how small changes can lead to huge shifts in the economy.
It's like we're finally realizing that the economy isn't this cold, unfeeling machine, but something that's driven by real people.
I like that. And Farmer believes this new way of thinking, moving away from the simple models and embracing the complexity, is absolutely crucial if we want to create a better future for everyone, one that's more stable, fairer, and more prosperous.
So are we saying that traditional economics is dead?
I don't think it's dead, it's more like it's evolving. The old theories and models still have their place, especially when we're dealing with simpler systems, or if we just need a basic understanding of how things work. But when we're trying to tackle the really big problems like climate change, financial crises, and inequality, we need better tools.
We need tools that can deal with the real world, with all of its chaos and unpredictability.
Yes. And that's where complexity economics comes in. It uses data, networks, and those agent-based models to make sense of it all. It's not about getting rid of the old ideas, but adding to them with newer, more powerful approaches. We have to change with the times.
We have to adapt just like the world around us is adapting.
Yes, exactly. And J. Doyne Farmer, with his background in both physics and economics, is one of the people leading the way into this exciting new frontier.
This is all incredibly fascinating, but I have to be honest, it also sounds incredibly complex.
Mm.
Are there any challenges in adopting this complexity-focused approach?
There are definitely some hurdles. One of the biggest is that you need a massive amount of data and computing power to actually run these agent-based models. The good news is that computers are getting more and more powerful, so it's becoming easier all the time. But there's another challenge that might be even harder. We need to change how people think.
Are we talking about the human element again?
Exactly. For decades, economics has been all about math and theory. So these agent-based models, with their focus on real-world data and accepting that we can't know everything, well, they can be a hard sell for people who are used to doing things the old way.
So it's not just about building better models, it's about building a new way of looking at things.
You hit the nail on the head. It takes time, an open mind, and a willingness to let go of old assumptions. But the payoff could be huge.
A better understanding of our complex world, and a better shot at making a future that is more stable, more equal, and more prosperous.
Exactly. And that's a future worth working towards, wouldn't you say?
Absolutely. But with all this talk about better models and changing how we think, I have to ask, even with all the data in the world, can we ever really know what the future holds?
That is the question, isn't it? It's a question that people have been asking for centuries. And honestly, even J. Doyne Farmer doesn't claim to have all the answers. So shall we dig into that a bit deeper?
So can we actually predict the future, even with these amazing models?
Yeah.
It's the big question, right?
It really is. And Farmer, even with his success predicting things like roulette, he's not claiming to be able to see the future. In fact, he's pretty upfront about the fact that prediction has its limits, especially when you're talking about something as complex as the economy.
So no crystal ball then?
I'm afraid not. The economy isn't like a machine where you can just plug in some numbers and get a guaranteed answer. It's always changing, always connected, and always throwing curveballs.
Okay, so where does that leave us? If we can't get a perfect prediction, what's the point of all these models and simulations anyway?
It's not about getting rid of uncertainty completely. It's more about understanding it, accepting it, and building systems that can roll with the punches. Think about it like this. You can't predict exactly when an earthquake will hit or how bad it'll be, but you can design buildings that can survive them.
So it's less about getting a perfect weather forecast and more about building earthquake-proof structures.
I like
that.
Exactly. It's about designing resilience into our systems, whether it's our financial markets, our energy grid, or our social safety nets. We have to remember that unexpected things are going to happen. The best way to deal with that isn't to cling to predictions that might be wrong. It's about being able to adapt.
It's about bending without breaking.
Exactly. And that's where this whole complexity economics approach really shines. By understanding how everything is connected, the feedback loops, and the unpredictable ways things can change, it gives us a way to not just predict, but also to prepare to adapt and to actually shape a future that's more resilient.
So instead of trying to fight uncertainty, we should be working with it, maybe even using it to our advantage.
You got it. It's about recognizing that we don't have all the answers, but always trying to learn more. It's about embracing the fact that the world is messy and complicated, and using that understanding to create systems that are stronger and more adaptable.
That's a pretty hopeful way to look at things.
Yeah.
We may not be able to predict the future down to the last detail, but we can definitely get better at navigating it and being prepared for whatever comes our way.
That's the power of looking at things through the lens of complexity. It doesn't promise easy answers or guarantees, but it gives us the tools and the understanding we need to ask better questions, to explore more possibilities, and ultimately to make smarter decisions in a world that's constantly changing.
This has been a fascinating deep dive into the world of complexity economics with J. Doyne Farmer as our guide. We've explored the limits of prediction, the importance of resilience, and how powerful it can be to embrace complexity. So as we wrap things up, we want to leave you with a final thought. As you go about your day, your work, your life, take a moment to think about the systems you're part of, the choices you make, and even the problems you face. How can you use this idea of complexity, this understanding of how everything is connected, to navigate your own path with more awareness and resilience? It's a question worth thinking about, and we hope this deep dive has given you the tools and the insights to start exploring those possibilities. Thanks for joining us.